Hello, my name is Owen Fisher, and the lecture I attended was The Coffee Ring Effect and the Physics of Breakfast, given by Peter Juncker. This particular talk was of interest to me because I drink a lot of coffee. This lecture showed how physics is part of our everyday lives and plays roles that are oftentimes overlooked. Dr. Juncker chose breakfast as an area of focus in order to demonstrate how fundamental physics are experienced by individuals on a daily basis. My interpretation of Dr. Juncker's interests and investments in this example is based on his desire to increase scientific literacy as well as scientific interest in the world as we know it. More specifically, Dr. Juncker used common breakfast food to explain physics. For example, he used coffee stains to elaborate on the phenomenon of what happens when coffee is spilled on surfaces. Coffee rings arise. Dr. Juncker explained that coffee rings drop edges pinned during evaporation and the diameter stays the same. Another food Juncker used to explain fundamental physics was scrambled eggs. The purpose of exploring the physics behind scrambled eggs was to use it as a reference for explaining soft matter. Throughout the lecture, I also learned that there are malaria tests and Alzheimer's tests based on the coffee ring effect. I also learned that drying drops of coffee contain polystyrene spheres. Generally, I gained a greater appreciation for the understanding of the way in which a lot of simple tasks that we experience every day work. The tests that result from this experimentation taught me that a lot of these seemingly elementary topics may actually provide complex solutions to modern-day problems. Outside of the lecture, some stuff I learned based off of research was that the coffee ring effect is utilized in convective deposition by researchers wanting to order particles on a substrate using capillary-driven assembly. Utilized by various groups including Velve at NC State and Gilchrist at Lehigh, using principles developed by Dimitrov and Nagayama, replacing a stationary droplet with an advancing meniscus drawn across a substrate. This process differs from dip coating in that evaporation drives flow along the substrate as opposed to gravity. Scientists have also utilized coffee ring drying pattern to pre-concentrate the protein solutions prior to the Raman analysis in so-called drop coating deposition Raman, or the DCDR technique. Hope you enjoyed my video, and thank you. Go Jackets!